Today we are going to discuss about the working principle of Francis turbine. Francis turbine is a um, impulse and reaction turbine. So let us see the cut view of Francis turbine. So high pressure, high head fluid comes from the through the casing, and design of casing is decreasing cross section area so that the velocity everywhere in the casing remains constant, and then finally it goes to IGV where there is a drop in the pressure and increase in the velocity, and which strikes to the blade or runner, and which is called impulse, and finally water travels to the blade and comes out with higher relative velocity because of drop in the pressure, and which causes the reaction to the rotor, and thus we can say that impulse, so the Francis turbine is a impulse and reaction turbine. So, and in detail we can discuss like this: the high pressure energy is partially converted into the velocity energy in the inlet guide vane, which is IGV. This is inlet guide vane, and remaining pressure drop occurs in turbine wheel blade, that is a runner blade. This is turbine wheel blade or runner blade. The pressure drop occurs in IGB causes increase in the velocity of the fluid which strikes on the runner blade, and this is called the impulse action. Turbine is designed in such a way that the cross-section area of turbine outlet is less than inlet, and due to this velocity of fluid is more than inlet. As there is increase in the velocity, and so pressure drop occurs in the runner blade. So here there is increase of relative velocity, but there is a drop in the pressure in the runner blade. The exit high velocity of fluid from the runner blade causes reaction to the blade, which helps in runner blade to rotate, and this is called the reaction of fluid on the blade. Thus Francis turbine is called impulse and reaction turbine. Francis turbine is used for relatively lower head and higher flow rate as compared to Pelton wheel turbine, but it is used for the higher head and lower flow rate as compared to Coupland turbine. This is another view of Francis turbine. You can see the fluid comes, you know, radially through the casing, and the area of cross section area of casing is this is inlet, this is outlet. So you see this is larger area, this is smaller area, so starts decreasing, and it and a fluid enters radially and then it goes out axially. So this is how it is written. Francis turbine is a radial inlet and axial outlet flow turbine, which is shown here. The high head water comes from the reservoir to inlet guide vane through casing of turbine. The casing is designed for decreasing cross-section area to have constant water velocity. Then water travels to IGB. The main function of IGB to convert high head fluid into velocity. The high velocity of fluid coming out from the nozzle or IGV, nozzle IGV is same thing, strikes to the runner blade of the turbine. Thus, the runner rotates due to impulse action of water. Water further travels to the runner blade where pressure drop occurs, and due to drop in pressure in the blade, high velocity of water comes out from the blade which causes reaction to the blade and helps in rotation. And this is how impulse and reaction occurs in Francis turbine. So we can say water comes radially and goes out axially for Francis turbine, and it is impulse and reaction turbine. The main function of IGB is also to control the flow of fluid for off-design operation of the turbine, and this is achieved by movement of IGV's vanes, which changes the area of IGV, and hence flow is controlled. Typical construction of Francis turbine is shown here. So now this is a schematic of runner blade or rotor, you can say, for the Francis turbine. You can see the flow of blade is radially at inlet and axial is outlet after entering radially, and then finally it goes to actually outlet. So for this is a typical diagram of runner blade for Francis turbine, where you can see these are blade runner blades. These are, and then these are the flow direction for outlet, and this is inlet for the turbine. There is another view. You can see the Francis turbine blade. If you see on the top, well, if you see the turbine on the top, runner blade on top, so you see this is the radial inlet for the turbine, and movement of this, and this is the flow of the fluid to the turbine blade. If you look at from the top, if you look at from the side view, this is the blade profile, and fluid is coming out axially. This is outlet. So two views is shown for the blade. One is top for inlet, and another is for side view for the outlet, to have more clarity of blade of Francis turbine. Then Francis turbine power is associated with mass flow rate, hydraulic head, and hydraulic efficiency. Turbine power is mass flow rate into hydraulic head into hydraulic efficiency upon 3600 into 1000. And further we can also write, there is another way we can express for the power is volumetric efficiency, volumetric flow into density, which is mass flow rate, into hydraulic head into hydraulic efficiency upon 3600 into 1000. So turbine power P is equal to Q into RT into HS into ES upon 3600 into 1000, where P is a turbine power, Q is a volumetric flow rate in meter cube per hour, RT is density of fluid, HS is hydraulic head joule per kg, ES is hydraulic efficiency is constants. So thank you for watching.